Oh, welcome back to my podcast. Uh, no, it's podcast, right? Um, yeah. After I decided to use the MALT90 dataset, I'm taking an overview for um, actually a brief review at the paper and also exploring the columns in the dataset. I think it's time to start cleaning that set and have some visualization on it. Uh, the dataset is quite clean. It's not messy like uh, actually some of astronomical dataset is quite um, you know you need some ETL processes or data cleaning requires um, inputting or deleting some rows, which is because some rows is actually not corrupted, but there are several technical limitations and so on. Fortunately, this is not the problem with this dataset. I think we can start an EDA process. Okay, let's share my screen. Yeah, here is the clean notebook. So, all right, let's try like, all right. I started in Google Drive, and I think I can share it. Not much. It's a bit laggy. My internet is not so good, and it's raining outside. Hey, where's my code? Okay, here you go. So I use the Google Collaboratory. It's quite simple and actually it's a Jupyter notebook and it's free with GPU, of course, but it's limited. Um, yeah, I started in my Drive directory and uh, I set the home directory into my Drive so I can perform any uh, terminal level command directly to my folder like this. I change the directory, and since I acquired the dataset from the Swinburne portal, so I will use Git for downloading. Actually, I downloaded directly into. Oh no, yes, I downloaded directly into my drive. Hmm. Actually, it's not taking a long time since Google Colab has fast internet connection, but yeah, maybe it's a bit timing. Yeah, okay, so actually I already downloaded and put it into folders. So let's, yeah, here is it. So if we take a look at this one, oh yeah, actually they downloaded again, so ignore it. Yeah, and I make a directory named MALT90 image, and then I unzip the tar file into the directory, and after that I make a specific directory about AIM. Sorry, I'm a bit coughed. I have allergy, but yeah, it often comes suddenly, and it's actually annoying. Yeah, I have my allergy like pollen, dust, and also sometimes my skin get burnt in summer. Okay. Since I already packed the AIM dataset, so I think it's better to take a look to the images. Let's go. Yeah, actually, this is the images that we downloaded. There are three sets of images: the AI and this one is AI. Hmm, let's get back to the parent directory. Oh, come on. Yeah, tonight we have Manchester United versus Chelsea at the Premier League. I think it's interesting. You want to watch? This is the classes. I'm not a fan of Manchester United, but uh, if they play, I think I'll support them since they don't play against Arsenal. I'm a fan of Arsenal, but my admiration for Ruud van Nistelrooy is what made me love Manchester United a little bit. But yeah, I have many memes for Manchester United actually. Ah, this is my machine learning dataset, so I think it's a little farther. Mm, so this is the images, I think. Yeah, GIM, MIM. Oh yeah, right. I already moved the AIM, and there are GIM and MIM left. Let's start with GIM. So we create a folder first, like this. Okay, and then I will move the GIM. The AIM is from the Atlas scale 870 micrometer. It's actually in grayscale. I think it's not for my machine learning. I already tried it. So I think I'll use another GIM. Okay, let's see. Yeah, this is processes. I think I'll use some data science package for the EDA. I'll import like Matplotlib maybe. Yeah, you can use OpenCV, but I don't advise you to use OpenCV. You can use Matplotlib, or maybe Pillow. You can use it, but I will start with them first. Yep, and here is the line info CSV. So we can use the head function to look at the Pandas data frame. So it's called data frame since you load the CSV file into some format of yeah, actually tables. Let's see. And I will take the first 10 rows. Actually 10 is the default number. You can change it with yeah, whatever. But I don't think they can load many rows. Okay, you can see we have the AG ID, AG name. It's from yeah, The naming reference is from the Atlas Gal catalog, and I think the NARD survey take that for the reference. Oh, sorry, what's that? And they are complementing the dataset. So actually, this kind of cross-match survey is often delivered in astrophysics. Yeah, they have classification and some astrophysical parameter. Like this is the, I think it's consensus velocity. So a velocity respected to the to a frame. Yeah, the object is far from our helios, so I think there's a heliocentric correction and so on. Or maybe, yeah, gravitation actually play a lot of parts. Oh, there are too many. There, we need to revisit the CSV file, but in Spark there are, I think there are some of them is 0, and 0 means, yeah, maybe actual 0 or, so let's see the class first. This one, as you know, the reference provided before, I should look at here. It's the previous paper I shown to you. Right, this one. Quiescence, protostellar, compact second ionization state of hydrogen, extended second ionization state of regions, PDRs, and arsenic. Okay, so as you can see, the number is actually quite balanced for A until Q, but says uncertain, right? Let me see. Oh no, there are so many uncertain, I think. The PDR is a bit a few, and the compact second ionization is actually quite few. Okay, there are many uncertain there. What should we do? Okay. Okay. I think I will consider uncertain as one class. I think we can discuss about it later. Maybe started it and training the machine learning classifier for known classes, and then we applied it to the uncertain. Okay. Yeah. Here is the dataset classification. Okay, I'm gonna take a look for the images. Can use PLT plot. Let me see. All right, we can use this. So I started JMark, PLT plot, and I will insert the image. I think it will take a long time since there are so many images. Oh no. Oh, I think it's flooding. Wait, what? It's okay. Oh, Neptune, what happened here? Oh. Okay, so it's recovered my notebook is crashed. Okay, I need to think about another. We'll use, we'll search it first. We'll use the traditional way. Where's our GIM? Yeah, this one. Okay, maybe I'm going to show you some of them. Yeah, this one. Yeah, your chosen. Oh, not that much. Hey, I forgot the folder. Wait a minute. We need to read the image first, right? If I'm not wrong. I should keep that. Okay. Oh. Okay. It's not plot, but it show. Oh, it's taking a long time. The image is not turbo, but oh, they already had access, but so I think access. Turn the access off. There's an option here. Where is it? So failed to access. False. Right? If I'm not wrong, you can turn the access off, so you can make a tidy image like this. The image is not quite big, I think. Yeah, they have contour from the center of the object here. Why you keep? Okay. Here's the image. Okay, and then yeah, this is the classification. I made a pie chart. So actually, you can slice the classification columns and use value counts to know how much it counts, and we set a label from the set of this column. And actually, I set a color here from the seaboard module, which is pastel. You can look at the Matplotlib or seaboard documentation to know more about coloring. Actually, you can create a killer presentation by them. That's what I did in my works as data scientist. Yep. I didn't. I create separated classes from this dataset to each classes. Uh, Actually, you can apply some function, but I made it manually. Use ggplot. I like this style of plot. So for each class, we have separated that frame. This is the A class. And an example, we want to know about the velocity distribution for each class. So we can use the histogram to plot the distribution for the velocity. I'll show you. The histogram will be superpositioned, and you can see how different the one class is with the other. You can see this is distribution. Yeah, it's quite few the compact H2 regions, and actually the consensus velocity distribution is not very different from one class to each other. Yeah, they are concentrated here, around here. I think, wait a minute. It's related to distance, or yeah, I think in the center they have. Okay, I'll think about it later. It's actually related to the physics of the gas. And then I'll make some classes here. GIM, let's say. And for each classes, we take the values. So actually it convert the Pandas data frame into a list. Yeah, like this. I want to store it in a list to make it better, to separate each of the classification into separated classes as separated folders. So it is GIM, right? Okay, I'll use the operating system module, so you can call a Linux command on Python. Like this one is actually make a directory for each class. Yes. Yeah, let's see that already made it here. And I'll place the GIM images from the parent directory into our separated directory, which is only consisted of GIM images here too. So yeah, don't forget to change the naming. Okay, let's try. And here, actually, I can use the OS package for splitting each classes into separated folder, but there is a Python package that actually automatically separated each classes. We need to install it first in Google Cloud because the package is not installed. Okay, I just import it, and then we set the ratio between the training, validation, and the test set for machine learning classification. So I think this package is actually useful. Okay, GIM. I like 42, it's from Hitchhiker's. Well, I forget the title. That's a book, I think. Hitchhiker's Guide to Galaxies. Yeah, I forget. My advisor told me about the novel. It's interesting, actually. Yeah, the Earth was taken by the alien, and you need to move abroad. Okay, copy the file. Hey, memorize disastrous SGIM. Oh, how can I say that? Let's pray that our images is not a request. Or I think I should do this again. If it happened, copy in the 0 files. Okay, let's see. So we use Pandas and Matplotlib and then some random package I found on PyPI, which is placeholder, and I found it helpful. Maybe you can use it for another machine learning projects instead of creating your own code for splitting. So let's do it for minutes. It's not that fast. Okay, we can see here. Let's see the progress, and I think if it's done, you can start the machine learning process. And because the classes is separated, the classes are separated, I think you can directly fed them into a class module named flow from directory. So it's actually widely used in CMM. Yeah, you don't need to create a function for each for fed the machine learning. And where is it? I think it's not created yet. All right, I'm waiting. Yeah, that's it, I think. Next, I will start the deep learning process for this because we already assigned each classes which the related images and the astrophysical parameter in the CSV, and we can fit them into the neural network directly for each classes. Yep, have a nice day.